Anybody want to say anything first?
Alrighty, let's get started. Hi, Mom.
Somebody else? I think you gotta be louder.
This is gonna be hard.
Hey, Joe.
All right, here we go. We are starting chapter 9. Chapter 9 is on transformation, reflections, rotations, lines of symmetry, all that kind of fun stuff. Well, you might have learned about it. We're going to go into a little bit more in depth today. Okay. So starting off today, we're going to learn how to use vectors to translate figures. So we have learned that a transformation moves or changes a figure in some way to produce a new figure. That new figure is called the image. The original figure is called the pre-image. When we have it, our pre-image is going to be called P and Q, or whatever letters they choose. The image, or after the translation or transformation, whatever we do, is going to be wrote as P prime and Q prime. That's as P with the tick and Q with the tick. If we have more than one, which is possible, then we have P double prime, or we have P triple prime, or we have 4, or P to the quadruple prime, which we usually just go P to the 4th. I don't think I've ever done a problem in math that's ever went past P to the triple prime. Okay, I don't think so. Or I don't think I've done it, so I don't believe you guys will either. So what we're going to start off with right away today is we have the quadrilateral ABCD, which is at -1, 2, -1, 5, 4, 6, and 4, 2. So if we quickly graph that, over here at 4, 6, 4, 2, we need to apply the translation xy going to x plus 3, y minus 1. So to do that, we start off with A, which is at -1, 2, B, -1, 5, C is at 4, 6, D is at 4, 2. And we're going to go to, change the color. I have to add 3 to my x value. -1 plus 3 is 2. And I have to subtract 1 from my y value, so that would be at 2 minus 1 is 1. B prime, -1 plus 3, 2, 5 minus 1, 4. C, which would be C prime, 4 plus 3, 7, 6 minus 1, 5. D prime, 4 plus 3 would be at 2 minus 1 would be at 1. This part pretty straightforward. You've already done it, yep. And we will... Okay, Corey doesn't remember, which is fine. But what happens is... Yes, Corey got a shout out in this video. Twice. Okay, we do get into tougher transformations and everything. When we graph this, 2, 1, then we're at 2, 4, then we're at 7, 5, then 7, 1. So the blue is the image, red is the pre-image. Okay. We do get to rules with rotations, reflections. Then we also will do this dealing with matrices. Okay, matrices get a lot tougher when you go to multiply. So we'll do this one quick. I'm not going to make you graph it. R is at 2, 2. S is at 5, 2. Gentlemen. P is at 3, 5. We're going 2. So R prime. 2 plus 1 is 3. 2 plus 2. S prime. 5 plus 1. 6. 2 plus 2. 3 plus 1. 4. 5 plus 2, 7. Pretty straightforward. Right, this is where it gets a little tricky, and I want you guys to make sure we know this one because you do have a couple like this on your homework tonight. Okay, we are told we need to find PQ, and we know where P prime and Q prime are at. So the way we do that, we're going to take the x value from P prime, set it equal to our x value in our rule. So negative 3 is going to equal x plus 4. We're just going to solve it like we normally would. Okay. The only thing I was going to quick do was 4, then it's going to equal to y minus 7. So instead of adding 4, we subtract 4. X equals negative 7. Over here, add 7. Y equals 11. So we know that P is at negative 7, 11. Now if I do, what? Y equals 11. Sorry about that. And if I do the same thing with Q, 2 equals x plus 4, subtract the 4, x equals negative 2. And do the same thing with the y. 1 equals y minus 7. Y equals 8. So then Q is at negative 2, 8. Isometry. We're only going to do one of these, and you're going to have... Not really. Okay. It's something good to know, but it's something that I would put money on it that it won't be on the test. Okay. You'll have one tonight on your homework, but isometry is just another word for congruence. We need to show the slope of all the sides are the same. Now we have to show that the distance is the same. Gentlemen, enough. Okay. So the way we do that, we need to go through. We need to find all 3 side lengths. So we'll start right with the easy one. AC, how long is this? 2. BC, how long is that? 3. And to find AB, we'll have to use the Pythagorean theorem because this is a right angle. We have 2 squared plus 3 squared. And I'll take the square root. 2 squared is 9, or 3 squared is 9. 4 plus 9, 13. Good question that was asked earlier. Do I need to go any further down? Heck no. Don't break it down any further. Square root of 13. Okay. Now we've got to check the red one. A prime, B prime, A prime, C prime, B prime, C prime. What is the distance of A prime, C prime? 2. That's because that is the up 3. That's the third point up. What's the distance of C prime, B prime? 3. And again, if we do A prime, B prime, you're going to get square root of 13. So I'm just going to quick look. AB, is that the same as A prime, B prime? Yep. AC, is that the same as A prime, C prime? Yep. BC, is that the same as B prime, C prime? Yep. Guess what? That's only half the problem. Okay. Now we've got to go through and do the slopes. So if I do, I'm going to kind of shorten it up for you guys here. AC, A prime, C prime. What is the slope of a line that goes straight up and down? Is it 0? No. Not infinite. Undefined. Then I have CB, which is the same as C prime, B prime. What is the slope of a line that goes straight across? 0. And the last one, AB, A prime, B prime. Because, remember this, how far up or down does this go? 0, 0 divided by how far did this go? 0 divided by 3, 0. Undefined, I go up 2, and then I go over 0. Can I divide by 0? Nope. No, only Chuck Norris can, and he did it twice. Chuck Norris divided by 0 twice. Yep. Okay, what's my slope of AB or A prime, B prime? -2, 3. Now that we've showed that the distances are the same and the slopes are the same, we can say this is an isometry. Again, this isn't going to be very huge thing to know. Throwing it out there so you guys know it. Alright, so in example 2, we need to write this rule. Let's look at the rule for example 2. Example 1. Okay, I was just on example 2. I need to go from A prime to A, C prime to C, B prime to B. So on this one, I'm always going to start my rules out as X, Y going to. Okay. What did I have to do to my X values to go from A prime to A? Did I have to add, subtract? Well, if I'm going to my right, I always add. How many did I add? Added 4. So my rule would be X plus 4, not Y. And then, how far down did I have to go on my Y? 1. Is that add 1 or subtract 1? Subtract 1. Alright, here we go. This is the fun part. I like vectors a lot. You start to deal with vectors a little bit here, but then if you do much physics in high school and college level, you will have chapters, and if you actually go to be a physicist, you will have classes on vectors. Or if you're watching Despicable Me or whatever the show is, whatever it is. Huh? I-cup? Ice. Alright, we see. Yes, I'd probably say a lot of dumb things. Okay. Alright, quickly. And even vectors. Around here, farmers don't really worry about it. But if you're on a mountainy area, or a very hilly area, you might have a vector field done of your field to see where's water going to run, where's water going to lay or sit. Do you do that all the time? Okay, I don't know. Yeah. A vector field, let me pull one up. Vector field, let me see which one was I looking at. Right here. Look at this vector field. This is a vector field. I don't know what it is, but this shows direction of movement and how it relates. So if this was in your field, right over here on the edge, this is probably a high spot. Right here will be kind of a low spot. Another high spot. Water's going to travel down and then this way. A lot of water is going to be traveling this way. It's probably between two hills. That's how I would read it. Okay. But anyway, on a vector, we have a couple key things. First one is our initial point. Our initial point is the point without the arrow. So our initial point here is A. Our terminal point is the ending point, the point with the arrow, which is B. The way we write a vector is always starting with the initial point, ending with the terminal point. So this vector would be AB with an arrow on top towards the terminal point. Our book will say to do this way with just one little arrow on top. Either way is acceptable for me. Okay. Our components. Here's the major thing. On our components, our horizontal component is how far we went. So how far did this horizontal component go? 1, 2, 3, 4, 5, 6, 7, 8, 9. Horizontal component is 9. And then our vertical component is 3. So if we were to write a component form of vector AB, it is going to be angle bracket, normal parenthesis will not work. I'll count it wrong. 9, 3, angle bracket. Angle brackets represent a vector. That's just what we have accepted. Okay, kind of like the straight railroad tracks is absolute value. It's just what it is. Absolute value is just a bar on each side. Okay. All right, here we go. We need to identify, gentlemen. We need to identify the vector and write its component form. So what's my vector for the first one? BC. And what's my horizontal component for this vector? I count over 9. It is kind of tough to see. Over 9. And then I go down 2. Negative 2 because it's going down. Yep, you have to start a B because it doesn't have the arrow. Okay. My next one, what's my vector component, or my ST? One, two, three. Okay, how far over did we go? I count 1, 2, 3, 4, 5, 6, 7, 8. So that can be positive or negative? Negative. And I didn't go up or down, so that's at 0. Main thing to remember here for vectors, negative just means direction, which way I'm going. So if I'm thinking that's a positive, this way is a negative, I'm going up, that's a positive, down, that's a negative. Okay. And yes, I did shut the mic off on you. Oh, what's that? Gentlemen. Okay, we have 0, 3, 2, 4, 1, 0. Okay, guys. All right, so we have triangle ABC drawn here. We need to apply the vector 5, 1, which says I move my x 5, y, -1. We're going to do it in 2 parts. So I'm going to use green dots to show where we would be after the first one, and we'll draw the actual one in red. So moving, do I move right or left 5? Right 5. So I'd have a dot there. 1, 2, 3, 4, 5, dot there. Dot there. Now we have to do our y component. Do I move up or down? Down 1. So I'm down here, here, here. That would be our image after the vector 5, -1. Okay. All right, last couple questions. You are on a boat. You're traveling from A to D. You hit a storm, you get bumped up to B. Then you hit another storm, you get bumped down to C. Just like you're on the middle from Gilligan's Island. Okay. Okay. Now you got that song in my head. I don't sing though, luckily. Once we get done with the video, I'll show it to you, Corey. No, because I want to get done with this. Okay. All right. So A to B. What is the vector component going from A to B? What is the vector component going from A to B? 12, 4. All right. How about if I went B to C? 4, -2. Okay. How about if I went A to C? Be 16, 2. Oh. Let's go like this. Let's go C to D now. Let's finish our trip. I would be going 2, 3.
I'm sorry.
All right. Let's. Well, if I went from C to D, well, I went 2 units and up 3 units. Okay. All right. Yeah.